Chapter 9, Stress Transformation, example number 4. So in this example, we want to study the effect we want to calculate the principal stresses on a sample handling a shearing stress at a two plate with the angle between them like a 60-degree, 30-degree to the x-axis for the first plate and the other one another 30-degree for the other plate. So the shear is a square root of 3 times p and a normal stress of 2p applies at each of those plates. So let's see if we want to translate this plate on Mohr circle, how can we do that? So do you remember if we call this point A and B? So this plate is shown by a point A at the Mohr circle, which is consists of a tau at y-axis and sigma in x-axis, and the other one is the other plate goes by a point B on the Mohr circle. If you have a 30-degree, it goes by 60 on Mohr circle. That's the principle of Mohr circle, and let's see how we can uh, get the so point A in Mohr circle is it goes by 2p normal and a shear of square root of p. And how is that? Do you remember we talk about the direction if a shear tends to rotate the element in a clockwise direction, the point goes at the top of x-axis. So point A goes at the top of x-axis by the amount of shear stress. That's a square root of p. And likewise, if a shear if a shear tends to rotate the below element in counterclockwise direction, it just goes below. So a clockwise comes at the top and a counterclockwise goes at the bottom of Mohr circle. So we have a specification of those 2 points, and let's work around the Mohr circle to get the principles. Let's see how that goes. So if this is 60-degree, the other 30 also is translate by doubled in a Mohr circle, so that's 60-degree as well. So if this is 60, this is 90-degree, that should be 30-degree. We do know that the A to H, which is the height of plate A, is exactly the amount of a shear stress, so that's a square root of 3 times P. And if we want to calculate the AC, which is the diagonal here, and that's the radius, that's AC times cosine of 30. That's AC times cosine of 30, AC cosine of 30. Let me highlight that. AC cosine of 30 goes by AH. So in that sense, AC is just simply AC over cosine of 30. We do know the amount of AH, so that's the AH, that's a square root of P. Mhm. So that just comes here, and cosine of 30 is a square root of 3 over P. So that's a square root of P over square root of a square root of 3 times P over square root of 3 over 2, and that goes by 2P. So we do know our radius is 2P. What else do we know? That AC is 2p and that's also equal to the radius. What else do we know? Let's see if we want to know what OC is from O center to center of or origin to center of the Mohr circle, that's equal to 2OH. So it consists of O to H, OH plus H to C plus H to C. That's our O to C. And OC we simply, for OH, we simply know that's the normal component of plate A, which is 2p, because the specification of this point is like this, a 2p and the square root of 3p. So the first component is 2 times p is here. Uh-huh, that's 2p. That's 2p from O to H normal in normal uh, in x-axis, which represent the normal stress. And HC, which is here, if you want to calculate HC, that's just simply R cosine of 60. And cosine of 60 is a half, 1 over 2. R over 2 is equal to 2p divided by 2 is p. So in that sense, we do have the uh, for calculation of principals, we do know sigma max is average plus R, sigma mean is average minus R. So if this is average, average minus R get us to sigma minimum, the average which is OC, and OC we just calculated to be from the previous part, that was 2p plus p. This part was 2p, which comes from here, plus HC, which is R cosine of 60. R is 2c times cosine of 60, which is 1 over 2. That gives us another p, and it just goes by 3p. So sigma average is 3p plus R, which is 2p, gives us a 5p for sigma max. That's 5p. And OC, which is 3p minus R, which is 2p, p gives us sigma minimum. So that you can see how easily you can solve the different configuration of Mohr circle just by of a stress transformation for any kind of shape and form by Mohr circle. Thank you.